Yay! Subscribe!
Hey yo, welcome back. On tonight's homework, we're still working on these linear function-based CLEP questions. And really these are just variations on questions that you can find in the College Board official study guide. And from what I've heard, the test should be pretty similar to that. So you can kind of expect similar questions to appear on the CLEP exam as well. Maybe not exactly the same, but using the same techniques and algebraic properties and that sort of thing. So number one says a data processing company has budgeted $20,000 for the purchase of 9 computers. The 9 computers are to be chosen from 2 models, Model X and Model Y. If a Model X computer costs $2,000 and a Model Y computer costs $3,000, how many Model X computers did the company purchase to use exactly the budgeted money? So there's really 2 pieces of information here. There's information about how many total computers are being purchased, and also how much money is being spent in total and for each one. So we've got Model X and Model Y, so I'm just going to use X and Y to represent the number of computers that they should purchase. So X and Y, I'm just going to make a note here, represent the number of computers being purchased. Well, okay. So that way, I just want to lay that out there so as we're working through these, we kind of know what X and Y are representing here. So if X and Y represent the number of computers being purchased, and we know we bought a total of 9 computers, the first equation we want to set up here is going to be X plus Y equals 9. So no matter how, however many computers we buy, they need to add up to 9. Now that number is pretty small, so you could probably get away if you get lost in the algebra and you're just, not really sure where to go from there. You can guess and check your way through this problem because there's only a couple options here, right? 0 and 9, 1 and 8, 2 and 7, and so on. So you can kind of work your way towards the solution that way. Just kind of guess and check, make a guess, see what the total cost would be, and then adjust based on that. But I'm going to show you how to work this purely algebraically, no guessing and checking going on. But know that you could get away with guessing and checking the problem. Okay, so that's the first piece of information, the number of computers being purchased total. The second piece of information is about the cost. So what we're going to end up doing here is set up a system of equations that we can solve for X and Y. So now Model X, what did it cost? $2,000 for Model X. I'm going to multiply each computer that we purchase, that's a Model X, for $2,000, or by $2,000. And the Model Y computers cost $3,000. That one must be a Mac. Okay. All right, so our system's set up here. We've got 2 equations with 2 variables. This is the system that we need to solve for X and Y. So the first thing I'm going to want to do here is rewrite this top equation so that I isolate one of my variables. Overall, the strategy that I'm going to use is after I rearrange this first equation, I'm going to plug that into the second and then go through the solving process to basically get my answer. So if I subtract X from both sides here, we can get Y equals 9 minus X. And so since I know now that Y equals 9 minus X, I can take this expression and substitute it into Y for the second equation. Remember, that's what Y equals. And I can use that to solve for X. And once I have X, I can get Y just pretty much immediately because, like, let's say I find X to be 5, so I got to add up to 9, Y would be 4, right? So I'm not saying that's the answer. I don't know what the answer is yet, but we'll figure it out here momentarily. So yeah, I'm going to take this expression, this 9 minus X, since that's what Y equals, and I'm going to stick it right here. Replace this Y, 9 minus X. Be careful doing that. In this particular problem, well, I guess, yeah, it would make a difference. You got to make sure that you're going to multiply this 3,000. I'm talking and I didn't type the X. Multiply this 3,000 by the entire Y, which means put it in parentheses, essentially. And when you go to distribute, make sure you're distributing. If this was a minus, for instance, you'd want to make sure to distribute that negative. It's not minus, so that's not really going to be a big deal, but just want to point that out there. So now I'm just going to solve for x. So I'm just solving a linear equation at this point. I'm going to start by using the distributive property, multiplying that 3,000 by 9, which I'm going to do over here on a calculator off camera. Probably didn't need a calculator for that. 27,000. Now, I'm so used to just jumping straight to the calculator that sometimes I could really just stop for 2 seconds and think and come up with an answer. But okay, so anyway, 3,000 times negative x is going to be negative 3,000x. Oh, that is not where the comma goes. There we go. Okay, so there we go. I use the distributive property. Now I want to combine like terms. So I've got 2,000 minus 3,000x. You might start thinking that's kind of weird that we're going to get a negative here, but it should all work out in the end. 1,000x would be what we get, combining 2,000 minus 3,000x. So put those two together. Now I'm going to subtract 29,000 from both sides. Oh, wait a minute. Hold up. Whoa. Let's back this up here. This should equal 20,000. See, this is what happens when I start working these problems and I'm talking my way through them. Wow. Made a big mistake there. Let's fix that. There we go. Yeah, I bet while you were watching this, thinking, what are you doing, Mr. Schuler? That should be 20,000. Come on now. Amateur hour? Yeah, it kind of is an amateur hour over here. All right, I'm just going to move this over just a bit. Fix this up so it looks nice. Is that good? Is that going to work for us? Move this over. Really want to get that thing. Let's just delete that. So yeah, I'll just redraw it. So this expression we plugged into. Right. Okay. Apologize for that, but now we should be good to go. What caught my eye was the fact that we were about to subtract 27,000 from each side. I was thinking, gosh, 9 minus 27,000, that is not going to work out very nicely. We really should be expecting a whole number here. So, yeah, that would cause some problems. But now we should be good. So 20,000, and I forgot the negative here. Geez. We just rework this problem? Okay, so 20,000 minus 27,000 is going to be negative 7,000. Okay, now we're rocking and rolling here. We got negative 1,000x equals negative 7,000. So dividing both sides by negative 1,000 is going to give me x equals 7, which is a pretty reasonable answer considering I'm only allowed to buy 9 computers here. So if x is 7, and there's only a total of 9 computers here, we got y equals 2. 7 plus 2 is 9. All right, so let's go ahead and answer the question in context here. So let's see, the company could purchase 7 Model X computers and 2 Model Y computers. Like I was saying up front, you can probably guess and check your way through this. If you just test out a couple combinations of X and Y and try to make it add up to $20,000, you could probably get it without doing any of this algebra. But the basic idea here is you want to set up a system and use substitution to solve it. You could also use elimination to solve this, but I just really like substitution. I just think it's, you can use it on anything. Elimination has, I don't know. It's not my favorite. Number 2, a cleaning company has budgeted $8,500 for the purchase of 13 vacuums. 13 vacuums are to be chosen from 2 models. Okay, so this is basically the same problem here. Okay, it should be the exact same setup here, except all the numbers are switched around. But basically, we're going to set up again a system of equations and solve it just really like this. Okay, so we got 13 vacuums. So we need to add up all the vacuums of Model X and Model Y should be 13. And then the second equation will have to do with the cost. Model X costs $500. Model Y costs $700. and we want to use exactly $8,500. Again, you could probably guess and check your way through this one, but I'm going to go through the algebra here with you. So first thing I'm going to do is I'm going to rewrite this equation, right? This is the system we're trying to solve. But I'm going to rewrite that first equation so that I can have something to substitute into the second one. I'm going to subtract x from both sides and get y equals 13 minus x. That expression, that 13 minus x, is going to go right here. Okay, I'm going to replace that y, 13 minus x. So I get 500x plus 700 times 13 minus x, and that should equal 8,500. So now I'll use the distributive property. I'm going to distribute that 700, so I get 500x plus 700 times 13. I'm just going to type that in. 700 times 13 is 9,100 minus 700x equals 8,500. All right, now we got to combine our like terms. We're going to see this play out very similar to how we saw the last one play out. We're going to say 500x minus 700x. Hopefully on this one we don't make the same errors though. But I think we're in the clear so far anyway. So yeah, and 500 minus 700 is going to be negative 200x. Now we want to subtract 9,100 from both sides. Okay, so we got 8,500 minus 9,100. You could probably check that in the calculator, but it's going to be negative 600. And then when I divide both sides by negative 200, I'm going to get x equals 3. So we want to purchase 3 of the Model X's, and since we want a total of 13 vacuums here, we want 10 of the Model Y's. So to answer this question, I'll just kind of copy what we did on the last one, since it's the same kind of idea here, except instead of buying computers, this company is purchasing vacuums. So 3 Model X and 10 Model Ys. All right, so that's I think both of there's only these two as far as like variations on the same problem. But the key things to remember is you're going to set up 2 equations. One will have to do with how many objects there are total. The second equation is all about the cost. Then you want to solve the system of equation using this method of substitution. And it shouldn't be too bad. There shouldn't be anything too crazy here. If you do get like a decimal down here, you might want to go back and check your work because of the nature of these problems. You can't buy half a vacuum, so you're not expecting any decimals in your. Now, number 3 and number 4, very similar problems here. What are the x-intercepts? Now, we know how to find the y-intercept, right? Both of these are in slope-intercept form. So the y-intercept's really easy to find, right? The y-intercept here is negative 6. The y-intercept over here is negative 9. But this is asking for the x-intercept, which isn't explicitly given to you in the equation, like the y-intercept. So to find the x-intercept, we have to do like what we did. This was, I think, during the first unit, when we had equations that were in standard form. Maybe it was in the second unit. I don't know. We've covered it once before. But basically, when your equation's in standard form, we graphed those equations by plugging in zeros to either x or y to find the x or y intercepts. And that same idea of plugging in a 0 into the y coordinate to find the x-intercept is what we're going to do here. We want to substitute 0 for y because the x-intercept is that point. Like if you have a graph like this, let's say we just have some random old line here. This point right here is what we're looking for, right? The x-intercept. This is where the graph crosses the x-axis. And no matter where you cross the x-axis, all these points along the x-axis, they're all x comma 0, something comma 0. The y coordinate for all x-intercepts is 0. So that's why to find the x-intercept, we want to plug in 0 for y and then solve for x. So that's really all there is to it. You just got to know what to do. So 0 equals negative 2/3 x minus 6, and we could solve this by first adding 6 to both sides. And to get rid of that negative 2/3, you could do one of two things. One is you could just divide both sides by negative 2/3. that's fine. If you'd like to take it step by step, like if that's too much of a jump for you, then we could multiply both sides by -3 here to get -18 equals 2x, and then divide both sides by 2. Either way, you're going to get the same answer. So whether you divide both sides by this fraction, 6 divided by -2/3, or multiply 6 by 3 and then divide by 2, you're going to get -9 either way. So that's your x-intercept, -9. The x-intercept of this one, we'll work it out very similarly by substituting in 0 for y. And then we'll solve for x. We'll start by adding 9 to both sides. And then same thing here. We can either divide both sides by -3/2, or multiply both sides by -2 and then divide by 3. So let's do the second, just because I think it's easier to do in your head. Right? Multiply both sides by -2 to get -18 equals 3x, and then divide both sides by 3 and we'll get, was that -6 equals x. So there's your x-intercept for number 4. Number 5 says the graph of which of the following is perpendicular to 4x minus 3y equals 7. We got 5 choices. Okay, so first, we need to find the slope of this, and then we can talk about how to figure out if a line's perpendicular. So to find the slope, we want to put this into slope-intercept form, which is that y equals mx plus b form. And the reason why we want to put it in that form is then we can identify what the slope is, which is the m. Right, this one right here, I can circle it without making too much of a mess here. Maybe I'll try blue. Yeah, that right there is the slope, right? So it's that m value. If I rewrite this in this form, I should know the m value. I'll start by subtracting 4x from both sides. That gives me -3y equals -4x plus 7. And then dividing both sides by -3. I'm going to get, a negative divided by negative is going to be positive 4/3 x, and then minus 7/3. I don't really care about the y-intercept here. All I really care about is the slope, because I'm trying to figure out which of these equations has a slope that's perpendicular to this. So if this slope is 4/3, then the perpendicular slope is going to be the opposite reciprocal of that number. The perpendicular slope that we're going for, that we want to look for, is going to be -3/4. Okay, so what we're going to do is we're going to go through each of these equations and do what we did to this one until we find the one that's perpendicular. Now, on a multiple choice question like this, if you have time, you want to check them all just to make sure you didn't miss anything or make a mistake. But if you're in a time crunch, you just, once you find that perpendicular slope, choose your answer and move on. You can always come back later if you do end up with extra time. We'll check each one of these. A here, we'll subtract 3x from both sides. It's going to give me 4y equals -3x plus 7. And then dividing everything by 4. Are we going to get lucky? Oh, wow, look at that. We got the slope we're looking for right off the bat. Okay, so, if you're taking the test, you're probably feeling pretty good about yourself. Like, hey, I found it. My answer is A. But let's check the rest of them just to make sure, because maybe we made a mistake. It's not a bad idea, since we have the time here, to go ahead and just check. Like I said, if you're on a time crunch and you're taking the CLEP test and the timer's ticking down, select A, move on. If you have time at the end, you can check the rest. But here in the video, let's just go through the rest just to make sure we didn't make a mistake here. So I'm going to subtract 3x. That's going to give me -4y equals -3x plus 7. And then dividing everything by 4, negative divided by negative is going to be positive. So this is not going to be perpendicular, because I need the opposite reciprocal. So this one is not going to work. Nope. Wrong one. Okay, so letter C, subtract. This one looks very similar, right? We subtract that 4x again, and then divide by 3. This one is going to be opposite. So B was reciprocal but not opposite. C looks like it's going to be opposite but not reciprocal. You really have to know what you're looking for to get this one right, because it looks like, and you really have to know, first of all, what the slope of the original one is, but also the fact that the perpendicular slope needs to be the opposite reciprocal, not just one or the other. So yeah, it's not going to be this one, right? This one is not correct. We'll go ahead and cross that one out. And then we'll check D. Pretty confident we got the right answer here, but just to double check here, we got negative 3y equals, and then if I subtract that 4x, it should be negative 4x plus 10. Then finally dividing by 3. Here's one where it is the opposite again, but not the reciprocal. We had one that was the reciprocal but not opposite. This one was opposite but not reciprocal. This one I think is actually ends up being just the same. So if the question, actually this is a good time to point this out, if the question was which one of these is parallel, this would be the right answer. Notice this has the same slope as the original one, 4/3. So yeah, this one would be parallel. It's not what we're looking for, but it's worth a note here. Actually, I'll do parallel. Actually, maybe it would be a good idea to write on each of these why it's not the right answer. So like this one was the reciprocal, but not parallel. Or, I'm sorry, parallel, but not opposite. And this one was the opposite, but not the reciprocal. Okay, this one is just going to be parallel. And then finally, the last one, I mean, this one doesn't even look like the other ones at all, so I'm guessing this one's just not going to work out. Yeah, if I divide everything by negative 4 here, the slope is just going to be completely different, right? If I divide here by negative 4, I'm just going to get 1x, which is just like nothing. It's not the reciprocal, it's not the opposite, it's not parallel, this is just like a bogus answer. So yeah, it's not going to be this one. Okay, so yeah, A is correct. We checked all the rest, and so we feel pretty good about that answer. Number 6 says, the owner of a small restaurant earned a profit of $280 during the first month of operation. According to the business model for the next 12 months, it's projected that the profit for each month after the first month will be $40 more than the profit of the preceding month. If P of M represents the profit for each month, M, and M equals 1, it represents the first month, which of the following functions best describes the business model? So I'm just going to lay it out. This is a trick question, okay? I mean, there's nothing like inherently wrong about how this is written, but 9 times out of 10, a rookie, someone just maybe not reading carefully is going to do this. They're going to say, all right, well, they earned $280 during the first month, and after that, they get 40 more than the preceding month. So you'd think, okay, well, I'm going to start with 280 and then add $40 a month, right? Wrong. Okay, this is actually not going to work because even though we're going to be seeing the same values like year to year that we would expect, like, okay, let me back up. You get $280 the first month. If you're going to increase by $40, then you'll expect $320 on the second month, right? So, but what's weird here is if I set up my equation like this, and I plug in M equals 1, I get 40 times 1 plus 280 is 320, which should be what I'm getting on the second month, not the first month. So I think, this is not going to be right, okay? But this is probably going to be the most likely chosen wrong answer. What I would suggest you do is make a little table and say, okay, well, in the first month, I got $280, right? So we'll just say month and profit. So the first month, we made $1. Second month is going to be $40 more than that. Oh, my lines just disappeared for some reason. Not sure what happened there. But yeah, the second month, we're expecting $320. Third month, be $360, and so on. Now, what I want to point out here is that even though if I plug in values here, I'm going to get these same numbers on the right, but they're going to be on the wrong month. Like if I plug in 1, right, I get 320. If I plug in 2, I get 360. So they're sort of offset by 1. And that's because this y-intercept needs to be the value that we're expecting when m is 0. So what we can do here is we can just work backwards in the table to figure out what that y-intercept or what that 0 value really should be. So I'm going to move this stuff down and give myself space, put m equals 0, and just work backwards in the table. I think that the table can really help kind of get your mind around it. So working backwards, I'm subtracting 40 rather than adding 40. So 280 minus 40 is going to be 240. That y-intercept should actually be 240, not 280. So my answer here is going to be P of m. Slope here is 40. But the y-intercept, which is really like, that's kind of the trick on this question, is going to be 240. So anyway, our answer here is C. All right, tricky question. I don't know if it's a trick question, but it definitely seems like it's trying to trick you. Okay. Just like at a glance, if I were to just read this real quick, I'm probably going to put D, just because that looks right, and that's kind of like how we write equations. But if you actually test the month number out, it'll be off by 1. So just be careful on this one. I'm really trying to emphasize, this one, because it's very easy to get the wrong answer on this one. Number 7. Okay, same idea here. So same kind of question. In fact, it's worded the same way. This is one that you can expect on that CLEP exam. So let's just do the same thing we did with the last one, where we make a table for m and p of m. Okay, this time, though, kind of knowing what's coming up, I'm going to start with 0, okay, and then go 1, 2. I really don't need to go to 3, but just for fun, I guess. Now this says on the first month, $360. So let's lay down that $360, and then every month after that, we're adding 60. Okay, so then we got $420. And 480. And if we work backwards, we get 300. So that's really the y-intercept we're looking for. And since we're adding 60, we can say that our choice, the correct answer here is going to be number 8 through 11. I don't know if I'm going to be able to fit all this on the screen here. I think, what am I going to do? Maybe I'll just hit page. Is that too small to see? I'm going to try to zoom in. Hopefully this isn't too small for you to see. I really want to try to fit all these, because this is a matching problem. So we got 5 graphs, and we're trying to match each description to the graph. And there's only 4 problems, so there's going to be one that we don't actually use. So this is really just all about understanding how slope works, how rate of change works, and being able to interpret a situation and match it to a graph. Number 8 says during a certain rainstorm, which it looks like they're all kind of worded the same way. So during a certain rainstorm, an empty rain barrel became filled with water. During the storm, the rain came down hard at first, followed by a lighter rain, followed by another heavy downpour. So what you need to understand here is that when it rains harder, the barrel should be filling faster, which means that our slope will be greater. And so the correct answer here is going to be C. Because if we look at C, we can look down here and we can see how the rate of change is faster here than it is in the middle, and then it goes faster again. So what's happening is the height of water in that barrel is going up faster, and then it kind of slows down during the lighter rain, and then it speeds up again with the heavy downpour. So you just want to make that association with steeper line should match up with heavier rain, because the more it's raining, the faster that the rain barrel is going to fill up. Number 9 says during a certain, okay, so same deal here, but this, it starts about halfway full, big hint, and then once the storm began, the rain fell lightly and consistently. So should not be any change in the slope, and also the height of the water should not start at 0, it should be start at, whatever halfway means. But the only one on here that doesn't start at 0 is going to be choice A. And we can see on choice A, we have a constant rate of change here. So we're not expecting like, the rain to be falling faster and slower. It's just the rain fell lightly and consistently. Number 10 says, during the storm, the rain came down at a steady rate until the barrel was full. Okay, so it started off empty, Okay, so it started at 0, and then it was just pretty consistent as far as the rain. So that's going to be E, the only one that has a constant rate of change and starts at 0. So the only difference between A and E here, really, as far as the description is concerned, that one starts halfway full and one starts empty. And the last one says an empty rain barrel became filled with water. During the storm, the rain fell lightly at first, so we're expecting a slower rate of change, followed by a heavy downpour, so the rate of change should increase, followed the wind. The wind became so forceful that the barrel was knocked over and began to lose water. This is the only scenario where we should expect the height to go down because the barrel got knocked over. The height of water should decrease. So if we look at choice D, that's really the only one that could possibly make sense here. You can see the light rain followed by the heavy downpour. Notice the slope, the rate of change increase. And then it got knocked over, which is why the height of the water is decreasing. Our answer here. That about wraps it up for tonight's homework. As always, please reach out if you have any questions. Thanks for watching, and y'all have a great day.